And looks
Welcome
like
to the show,
Bryan Nickel
Brian.
just. Bryan, thank you so much for being here. We appreciate it. We love the work that you've done. We've learned so much from you. So thanks for being here, Bryan.
Yeah, thank you for having me.
So, Bryan, they asked me a question that I didn't feel qualified to answer. So maybe I think it was George Bond.
Yes.
Bond.
Yes,
George
yes.
Bond. Could you put that question to Bryan?
Definitely. Hi, Brian. I've had a short discussion with you on Messenger at Facebook.
Yeah.
I believe you're working on the 9th edition at the moment, and I'm very eager to see those calculations for the heat problem, because I'm a retired civil engineer, so I understand a little bit about mathematics. So I'll be eager to have a look at those. But the question that I posed to Bob actually wasn't a question, but it was more about the addressing the heat problem, and I'd stated that there's really not one factor that can explain the criticisms towards creationists in this area, but I mentioned boundary conditions. And I'm sure you can expand a bit on boundary conditions and how they actually can be used to solve the heat problem.
Yeah, well, I think it can be used to understand it a little bit better, and to identify where I think a lot of the criticisms of hydroplate theory go wrong. So I won't say that we can just easily easily solve the heat problem for hydroplate theory, if you want to call it a heat problem, in terms of having some summation of numbers that just gives us an absolute, oh, this is solved, right? But I think where a lot of the criticisms go wrong is they tend to oversimplify hydroplate to the point that they so that they can analyze it, but then they leave out a whole lot of physics that's happening in the hydroplate scenario. And so I think what you're referring to is boundary conditions in terms of like boundary layers in a high-speed flow, things like that. Is that?
Well, I was specifically talking about space being a nearly infinite heat sink, for example. The heated air dramatically cools it as it expands. I think the other one is cooled particles could fall back onto Earth, neutralizing some of that heat as well.
Yeah.
And of course, the important one, and we all talk about the specific heat capacity of water. That's another factor that comes into play in terms of neutralizing the heat.
Yeah, I think there definitely plays a role in me reaching the conclusion that heat would not be able to transfer to the lower atmosphere in the way that so many critics believe that it did. And so far from critics that I've seen, what they do is they will just take a very simple thermodynamics equation that takes the specific heat of water times the mass of the atmosphere, and then they they solve basically for what would your final heat be if you added some percentage of kinetic energy that Walt estimates that the fountains needed in order to launch all the asteroids and comets and TNOs. So they'll just arbitrarily pick a seemingly really low percentage of that kinetic energy value, and then they'll apply it to this equation and come up with 3,000, or 300 degrees Fahrenheit increase in temperature of the atmosphere. But they've done that without and that's where they've oversimplified the problem, because they've done that without taking into account high speed flow has through a stagnant atmosphere. And that's really where they go wrong. They've oversimplified the problem, and so they've come up with an answer they like, but they've ignored a whole lot of very real physics that would be going on in the interaction between the high-speed hypersonic flow of the jetting fountains and the stagnant atmosphere.
So,
And
Brian, could I ask you the temperature of the water in the subterranean chamber? Walt has indication of how hot the water would have been, and that's why the natural thought is, well, when it's up on the surface, it's going to scald all life to death, even those on the ark. But how hot would the water have been in the chamber when the fountains erupted?
Right. So there's some indications from meteorites having like the iron nickel meteorites having a Widmanstätten pattern in them, and they know that results, to get that you need prolonged temperatures at 1300 degrees Fahrenheit. So that a rough estimate is that the waters of the Great Deep were started out below the crust at 1300 degrees Fahrenheit. And so many critics just assume that 1300 degrees Fahrenheit is what the atmosphere experienced. But remember, that's 60 to 30 miles below the crust where we're at 1300 degrees Fahrenheit. But when you allow a high temperature fluid to expand freely, we call that throttling in the engineering business. When it expands freely,
Hey, Brian, we're getting bad audio from you. Could you begin again? When it expands freely, what happens? We don't have a good connection.
Here, let's try this.
Yeah, it looks like it was about maybe 5 or 6 seconds there with a bad connection, but it looks like, Brian, looks like you're back.
Yeah. How's that?
Good.
Okay. You'd asked about the high temperatures, 1300 degree Fahrenheit temperatures of the fountains of the Great Deep. And so many critics assume that 1300 degrees Fahrenheit will be what the atmosphere experiences. But remember, that's 30 to 60 miles below the surface where those temperatures exist. And when you allow a high temperature, high pressure fluid to freely expand, the expansion itself causes there to be a rapid cooling of the fluid as it accelerates, basically. So in the engineering business, we call that throttling or free expansion through a nozzle. And that is absolutely what happens. I mean, that's relied upon in the physics of a rocket engine or a jet aircraft or anything like that. It is known that when you freely expand a fluid, it is going to cool down. So by the time you expand a fluid 30 to 60 miles, it definitely would have cooled down and gained tremendous kinetic energy by that time. Now, the exact amount of cooling and what the exact temperature is of the flow as it passes by the atmosphere, the lower atmosphere, I can't positively tell you what that would have been, but it certainly wouldn't have been 1300 degrees Fahrenheit. If you look at the throat of a rocket nozzle, for instance, the temperatures right at the throat are extremely high. And if you follow a plot of how temperature changes as it passes through the throat of a nozzle, like say a rocket nozzle, and enters into the expansion chamber, which is kind of that bell-shaped part of a rocket nozzle, the part that you can see, we know that the temperature drops rapidly from the nozzle. So by the time it exits the bell chamber of the rocket, those temperatures have cooled a tremendous amount. So definitely not 1300 degrees at the surface of Earth in the lower atmosphere.
Are there any heat problems with the drifting of the continents in the model whatsoever?
Yeah, that's been talked about a lot. I think one of the strengths of hydroplate theory is its explanation of shallow magma under the continents, which I think is actually a problem for other forms of, I'll say, geophysical models. So I think you probably have heard about the fact that magma below the crossover depth cannot rise. So the idea that plumes of magma that could come from the super dense outer liquid core of Earth could rise through the mantle, that is a fantasy as far as physics is concerned. And so where do we get these big calderas like under the Yellowstone, under Yellowstone Park and things? How do we explain that? I think hydroplate theory's strength is in providing a very real mechanism for where that heat came from. So I don't see the heat being a problem for hydroplate theory, simply because, yeah, we have lots of areas where there's tremendous amount of magma somewhere down there about in the region where we would have expected the granite crust to have crashed into and skidded against the mantle for a certain length of distance, as it slowed down. And so that's where that heat came from. And then, yeah, it melted a whole bunch of rock. And of course, we have a whole bunch of evidence from volcanic mountains, especially for North America here along the western edge of the continent. A lot of those mountains are volcanic, like Mount St. Helens and whatnot. And of course, when they erupt, they send off not just magma, but tremendous amount of steam and carbon dioxide. So that again plays right in with the hydroplate theory as to where that heat came from, why there's all that pressure, why that pressure is still pressurized. And so, yeah, I don't see it as a big problem. When you have tremendous heat, rock also is a great insulator for things that are heat. So yeah, you might have a lot of heat built up under the surface of the continents as they drifted and slid and compressed during the compression event. But the heat that we have down there that we know is shallow really just points to the hydroplate mechanism as a very valid mechanism for that. And it explains why there's that heat at that point in Earth.
Actually,
Bryan,
I'd be curious to ask, actually, if I can ask a real quick question, because everything you're saying is awesome and extremely helpful, Bryan. We've got a critic who typically uses arguments from, I'm sure you're aware, Tony Reed, where they say that we require miracles. I don't know if they completely understood everything you were saying, because what you were saying kind of goes against that argument where they say only a miracle can resolve the so-called heat problem, if you want to call it that. Well, is there any validity to that with people like Tony Reed and the critics are saying?
In terms of needing a miracle for hydroplate theory to explain heat, I would say no, we don't need a miracle for that at all. That's I think a lot of that, at least from what I've seen of Tony Reed's commentary on hydroplate, there's definitely some misunderstanding of what hydroplate theory is saying, and I think his videos on the subject, to me, they don't convey that he has grasped what hydroplate theory is about, or the mechanisms in it. That, or he's glossing over. I won't speak for him, but that's what it seems to be. One of those two cases.
Right, I would agree with that. And then they'll say that the removal of the heat, the excess heat, they'll say that only a miracle can explain that, which once again, would you say misunderstands, as you were saying, they're oversimplifying it?
Yeah. In fact, I've been working on a video for about 2 years now to answer this question in a way that will convey the very real sciences behind thermodynamics and heat transfer, and the very real physical phenomena that's happening in the hydroplate scenario, so that there's a more thorough and accurate presentation of hydroplate theory's heat management, we'll call it, because it's not a heat problem. It's just how, these mechanisms generate heat. There's certain mechanisms in hydroplate theory that would generate heat, but then the question is how does that heat move through the system, and what is our heat management say? And so it's not that there's a miracle required or that we have this amount of heat that we just don't know what to do with it. We know exactly how that heat moved around or would have moved around. I think critics tend to kind of jump to the problem before they've bothered to understand the physics that explains the problem.
Hey, Bryan, is Walt Brown qualified to evaluate the heat implications of his hydroplate theory?
That's a good point. I don't know Tony Reed's background or some of these other people's pedigrees who are critiquing hydroplate theory. I mean, certainly physicists should be able to come up with I'll say a more realistic and more fair critique of a heat management of hydroplate theory. But Walt's a mechanical engineer, and I think anybody who's been in the engineering field and interacted with other engineering students, I know I went to Montana State University for my degree in mechanical, and mechanical engineers are one of the most entrenched in the field of thermodynamics and heat transfer of any of the engineering disciplines, really. I mean, other disciplines like, say, for instance, aerodynamics and civil engineering, a lot of times when you have to go to take your thermodynamics courses for your rubric in those fields, you are pretty much very likely going to be having a mechanical engineer as your professor for those classes, because thermodynamics is right out of mechanical engineering's wheelhouse. So Walt is eminently qualified for that. He graduated from a little podunk school called Massachusetts Institute of Technology, and he graduated with his PhD there with a focus and emphasis on heat transfer. So Walt is by no means uninformed as far as the heat management in his own theory.
Walt actually worked in MIT's heat transfer lab, and he received his PhD from their heat transfer division in their engineering department. So he really is eminently qualified to consider, and he has throughout the entire development of his model for decades now, considered the heat generation and dissipation of the hydroplate theory. Yeah,
I think people hear mechanical engineering, it sounds like gears, but there's a whole half of the discipline that is dedicated to thermodynamics and heat transfer. So the big part of mechanical engineering.
You said that you were working on a video a while ago, doing all the math calculations. Is that still in the works, or are you still more working on the book?
Well, I've been doing kind of a little of both. I will say the video won't be all the math calculations. It'll have some calculations that just show the percentages of how much area is involved, and to give the viewer an understanding of things. It's a lot of things are very difficult to calculate, as far as like you just end up making so many assumptions that anybody could sit there and pick apart those assumptions. And so I'm a little hesitant to just, vomit a whole bunch of calculations into a video. I don't think it would help with understanding the concepts. The idea behind this video will be to show the physical interactions that have to take place, that we know would have taken place, and just show how those physical interactions are going to severely limit the amount of heat transfer that can happen with the lower atmosphere. And that's the main thing, because most everybody who's critiquing hydroplate theory will just immediately jump to a lot of adjectives describing how Earth would cook or boil or fry or whatever, and so the goal of this video is really just to educate as far as what type of physical phenomena were really truly involved in hydroplate theory, and show how you cannot just take some of the things that hydroplate theory proposes and then simplify it outside of what hydroplate theory proposes, and then come up with some supposed calculation that proves hydroplate theory has a problem. And that's really where I see most of the critiques having real difficulty in terms of being fair to what hydroplate theory is proposing.
Brian, one of the misconceptions is that this heat occurred on the first day. I mean, the flood occurred over 150 days.
Yeah, that's another.
Are they really taking into account that it wasn't over one day; it was over 150 days?
That's another thing that does come up. Even John Baumgartner has essentially done the equivalent of that, where when he's calculating the amount of energy it would take to produce, I think, all the deuterium that Walt claims, he says, well, if you'd have done that, you would have vaporized, the crust and the oceans and everything. Like, everything would have just been vaporized. And it's kind of interesting that he does that, because Walt, in his book, has a calculation where he did that very thing and said, yeah, if you take it over, zero time, then yeah, you add that much energy all at one time to, this much crustal mass and this much ocean and atmosphere mass, then yeah, it all vaporizes. But if you spread it out over 40 days, suddenly it's not a whole lot more intense than an LED light bulb. So time is a very important factor in this, and I think a lot of critiquers tend to skip that.
One of the questions from a critic was that a lot of the energy produced, Walt Brown said, was in the million, was 5,000 trillion H-bombs. And the question is on your screen right there. Love for you to ask what Walt Brown's high numbers are from the website, assuming a total energy of 2.2 times 10 to the 38th power. If you can see that anyway. But Walt Brown said something like 5,000 trillion H-bombs were going off. I don't know if that was during the fountains of the Great Deep breaking forth, and if that would be a numerical heat problem.
So I think that in context of the hydroplate theory, what Walt was, how he came up with those numbers was that he was just saying, how much energy would it take to get that much mass to exit Earth's gravitational sphere of influence? So it needs to be accelerated to at least 7 miles per second in order for material that exits in the fountains to never come back to Earth. And so that's how he arrived at that kinetic energy estimate. And so that would be, you could accelerate one rock at a time, or, one packet of water at a time, doing that. So yeah, those very large kinetic energy estimates are not something that all have to happen on like the first day. It happened over 40 days is what Walt claims.
I see. And that was kind of like the highest velocity to eject something like an asteroid would have been, to push it in.
That would have been the minimum velocity to get any object of any size, whatever its mass is, you've got to get that mass accelerated to 7 miles per second in order for it to leave Earth and not gravitationally be attracted back down to Earth. So you got to get outside the sphere of influence. So for it to go into orbit basically around the sun and not come back and orbit Earth or hit Earth, you've got to get above 7 miles per second. That would be the minimum velocity, and some near hyperbolic comets indicate that they might have been launched at up to 30 plus miles per second.
Hyperbolic, going retrograde as compared to the sun's rotation and the earth and the planet's rotation.
Yeah.
Can we make two clarifications? One, when the debris was being ejected from the earth by the fountains, the earth didn't eject an asteroid. It ejected millions of boulders, rocks, tremendous amount of water, debris, and the asteroid formed over time in space. So one clarification. Yeah. Earlier, I mentioned, I realized I misspoke, that the compression event, the continents sliding, I think I implied it happened after 40 days. It didn't. It happened months later in the flood.
Got it.
Yeah, that was that first one too, Bob. Thank you for that. That is a very good point. And one common misconception is that whole asteroids or whole TNOs or whatever were being launched. Those formed later. Basically, trillions of tiny, relatively small rocks were getting launched, but not extremely large house-size objects necessarily. Some of them might have been up to that. Like there is some indication that some meteorite, or I guess it'd be meteoroids, are spinning at a speed that would indicate that anything bigger than about 650 feet in diameter would probably fly apart. So up to say 650 feet in diameter, but no larger probably than that.
We have a really lousy short animation that we created. Maybe I could show that, but Bryan, I hate to ask, I'm not the host here, but could you describe that picture on the screen? Are those actually is that your watch?
Yeah. Yeah. That's my watch, and that's my hands, and that was at my kitchen table with a propane torch, that you'd use for soldering pipes. So that was an attempt to show how heat transfer works and doesn't necessarily transfer heat into the atmosphere in the way that many people would think, without going into a hour-long discussion in the Hydroplate series of videos. So that was just kind of, sometimes a picture is worth more than a lot of explanation, but apparently that wasn't the case, which is why I'm doing the video now to be a little more specific.
Could you keep your hands there for what, like 5 seconds?
Oh no, I could have let the whole bottle run out.
And the claim, like from Tony Reed and others, we list 20 of their specific heat objections. The claim that all this energy, it's just going to average out. And so that's not like a law of physics that the energy available averages out. And we use this, an actual photograph of a test, a rocket test, to make the point that just because you have thousands of degrees at the nozzle doesn't mean you have thousands of degrees 100 feet away.
Yeah, that's kind of a larger example of my hands in front of the propane torch. And that's one assumption, is that when you do these calculations using basically finding the mass involved in the energy and then solving for what your final temperature would be, well, that's assuming that you're getting perfect mixing. It's assuming that you even have a mechanism that allows mixing. And nobody who's criticized hydroplate theory has ever even bothered to talk about that. They just want to pick a percentage that they feel is reasonable, but they don't have any scientific justification for why it's reasonable. And so what I want to do with this video is show, if you go into the mechanisms, you see how arbitrarily picking a percentage is not so reasonable.
So if they said 0.1% of the exhaust energy was in that snow 100 feet away, it would have melted the snow. But in fact, that arbitrary percent is not relevant to the real world.
Yeah, and the further away you get, the harder and harder it is to mix. And so we're simplifying something into an experiment that maybe, you know, a first year physics student does in a very controlled environment on their table, where yeah, you can wait, and yeah, if you add this much heat to your box that's well insulated, you can roughly get, you know, some average temperature over time, and conclude that, oh, you know, that works for that scenario, but that's in a very controlled and closed system. But now we're talking on a global scale. How do you get thorough atmospheric mixing to the point where you could conclusively say that some people in a boat at the surface would absolutely for sure die? And that becomes much more complicated. And so this video will show and highlight that, just very similar to, you know, if you, I guess, wanted to use a solid rocket booster to melt snow, you'd have kind of a problem doing that on snow that's just not too far adjacent from the side of the nozzle that's at 8 or 10,000 degrees. So,
wow. Well, if the fountains came up with tremendous heat, that doesn't mean they're going to overheat the atmosphere.
Could you repeat that, Bob?
If the fountains did come up with tremendous heat, that doesn't mean they're going to overheat the atmosphere, because of this directed energy and the way the real world works instead of back of the envelope calculations.
And the you know, many will just take, you know, an arbitrary percentage of kinetic energy and then say, well, if that mixed with the atmosphere, everything would fry and boil. And well, yeah, even that, the equation they use, that's an average temperature, so you can't conclusively say that every single section of air in the entire atmosphere has for sure reached that temperature, especially when with the Earth you're dealing with an open system. So they're really not comparing apples to apples in that case.
Brian, you mentioned the escape velocity earlier. I read that the absolute zero is, I think, around 100 kilometers above Earth's surface. So considering the escape velocity, you'd reach that heat would reach zero in what, 2 to 5 or 10 seconds?
Yeah, certainly depending on the speed that was reached for a given pulse. I don't know which, I'm not sure the source that you're saying the temperature, the atmosphere, as far as altitude. You can look those things up with a Google search. I think temperature is a little misleading as far as going with what the temperature of the atmosphere is above the Earth. There's a lot of factors that affect that. And remember, temperature is just a way of telling us, giving us an idea of the heat of something. But you could have one molecule that's 5,000 degrees as far as its energy, its temperature. But if it struck you, you know, unless it hit a nerve ending or something, you'd probably not notice damage from it, right? So it's when you have trillions of those molecules at that temperature with that amount of energy that it transfers into you and you get burned. So, and the reason I'm bringing that up is, you know, a couple hundred miles above Earth's atmosphere, if you look that up on Google, you'll find that the temperature actually starts to rise the higher up you go in the atmosphere, you know, as cosmic rays and stuff from the sun interact with the molecules that are up there. But those molecules are so spread out that there's not enough heat in all those molecules to heat something effectively. So the thing is that there's so much space, literally space, available between all those molecules that there's tremendous potential for something rising up through the atmosphere to be very, you know, it's able to radiate its heat out because there's no atmosphere to interact with. In general, there's not really that many molecules to interact with. So the more of that clouds as well, you know, the more ejecta that is launched above Earth, the less and less the sun's rays are able to hit those molecules. They might hit the outer molecules and excite them, but the stuff that's behind it gets more and more shaded, we'll say, from Earth's rays, and so those have the ability to radiate their heat more effectively. So yeah, in terms of the launch speeds, material that was 1,300 degrees down at the base, you know, if it gets accelerated to 7 miles a second, the lower atmosphere where all life is about 7 miles. So it would, you know, if it was going 7 miles a second, by the time it had accelerated for 60 miles from the base, it would be traveling at 7 miles a second. So it'd be in Earth's atmosphere or passing through Earth's atmosphere in just 1 second. So yeah, it really wouldn't have much time to interact. And then there's a whole host of aerodynamic reasons why the high-speed flow from the fountains would not be able to interact with and mix with the essentially stagnant atmosphere just adjacent to, just to the sides of the flow. Yeah,
thank you for that. I asked the question of Bob earlier, but he suggested I probably wait until you came in onto the stream. It's to do with the Clausius-Clapeyron relationship. You aware of that at all?
Yeah, the Clausius-Clapeyron equation. Yeah.
Yeah, I know a bit about it, but I'm not sure the audience knows much. If you just like to expand on it a little bit.
Yeah. Okay. It's what's used in order to come up with the steam tables for water, and it's a relationship where the pressure and the temperature are related in such a way that if the pressure drops, then the temperature, in order for the equation to balance, has to drop. So, so that's, I guess, without going into, I think, a lot of detail that would probably be pretty difficult to follow, and maybe, at least for me right now, having not prepared specifically for that, might be difficult for me to even get through. But yeah, basically the two variables in the equation are pressure and temperature, and so if temperature or pressure drop, then the other variable also has to drop. And so to that end, the pressure at in the fountains down at the base was extremely high pressure, and it was getting accelerated and dropping in pressure because of that acceleration and because of the expansion.
Yeah, Bob mentioned that when the fountains of the deep broke up, there was enormous erosion from the floor and the ceiling where the water was actually contained in. So what I'm saying is, when you have that much erosion occurring, the pressure above it is reduced, and therefore the temperature would drop as a result.
I guess I'm not quite following the erosion side of things. What was the thought there?
Well, consider the water contained under the crust. Okay, as it escapes, it's actually eroding the floor and the ceiling of that chamber. But as it's eroding that material, the pressure on that material is then less because there's less material above it. Therefore, the temperature would reduce as well.
The temperature of the, are you saying
of the water? Of the water.
Of the water.
If the overlying crust is going from 60 miles down to 50 to 40, then that's another factor in reducing the pressure. George, you're making that point?
Yes, correct.
Yeah, I guess I have to think about that. You're talking about like the eroded particles in there going from high pressure to low?
No, well, the eroded particles would be removed, but the amount of material above it would be less, because as Bob mentioned, you'd go from 60 miles thick to 50 miles thick to 40 miles thick, because you've had a lot of erosion from that sealing of the chamber.
Okay, I think I'm understanding a little better now. So, yeah, and not only that, but as the fluid starts to move, just by definition, in fluids, you study fluid mechanics. When a fluid starts to move, it by definition drops in pressure. I think is that what you're talking about?
Yeah.
And at the beginning of the fountains erupting, I believe Walt has calculated the pressure at about 370,000 pounds per square inch. Almost unimaginable. But then at the surface, the 1 atmosphere is like 15 pounds per square inch. So a tremendous decrease in pressure from the movement of the water and the expansion of the water. That's got to be overwhelmingly the most significant factor, the decrease in pressure.
Yeah. In fact, if you think about it, if I was to describe a scenario and we weren't talking about the Earth, and I just said I have this box, and it's inside the box, the air in this box is at 300,000 psi, and I've got a little thin layer of air outside of this box that's an inch thick, and that's exerting some amount of pressure on this box. And then outside of that air, I've got a vacuum pulled on it.
Mm-hmm.
And now I'm going to open a fissure in this box and let all that air inside do whatever it wants to do. And on the one end, I have 300,000 psi. I've got an inch layer of stagnant air, and then I've got a vacuum pulled on it. What kind of speeds and accelerations and expansions do you think you're going to see?
Yeah.
I hope we just got a preview of a segment of your heat video, Brian.
Yeah, there's this part in there where I talk about it.
Okay. Hey, George and the guys, Donnie, Roa, Matt. Earlier we mentioned the comet formation. We've got a really rough draft of an animation. It's not for public consumption, really. It's unlisted on our YouTube channel. But maybe I could hit play here, and you guys could see this to sort of visualize the concept. Is that right? Okay, I'll hit play.
Yeah.
So the debris coming up from the crack that wrapped around the Earth, and they're all individual rocks, particles with water vapor, water turning to ice, and dust, tremendous amount of debris. Now the animation gets really rough here, apologize. But imagine that's a rock that's the core, and other debris that's orbiting the core that'll become an asteroid or a comet. And so that happens over time. And then over a period of years, you end up with what's eventually going to be a comet. So that idea.
Yeah, I know SFT had a few more questions to ask. Maybe this is a good opportunity, Standing, to do that.
Yeah, no, I was just engaging the chat. I wanted to say thank you for the super stickers, super chats, both to Brian and Bob. This has been a blessing. I mean, we're going on almost 2.5 hours, and this has flown by. So much good information. This is extremely rewatchable. And like I said, just a lot of good data and a lot of good evidence that you guys are providing us. Now, I wasn't sure how, because we kind of went on a discussion on the heat and various related topics. I'm not too sure if Bob, I know the last time I'm not sure if there was a few other things you wanted to touch on, or in regards to the outline that we had laid out, or
well, we had evidence specifically not only tremendous evidence for the global flood, but evidence for the hydroplate theory.
Right. Yes, that's what I'm looking at on the outline. That I didn't want to derail it. I wanted to make sure that you were feeling, Bob, that you were able to, get out everything that you felt necessary.
Yeah. So, Brian, I don't know what your time is like, but maybe we could just quickly go through some of these bullet points of evidence, not only for the global flood, like dinosaur soft tissue and trillions of dead things laid down by water, but specifically evidence for the hydroplate theory that creationists really, I think, could celebrate so much evidence. Brian, you have a little bit of time to look at some of this?
Yeah, maybe a little.
All right. So we have 20 Bible verses that uniquely support the hydroplate theory, uniquely. And when other authors of the other creation models were asked, what Bible verses uniquely support like catastrophic plate tectonics or the impact model or the vapor canopy model, there's like one verse that seems like maybe it supports the vapor canopy theory, and no verses that support catastrophic plate tectonics. Like there's nothing that says that the edges of the continent began to plummet because they got 700 degrees cooler. You know what I mean? But so many verses seem to explicitly reference the hydroplate theory. The perfect cosmos now has cratered Mercury, Venus, Earth, Moon, and Mars. So God wouldn't have created the perfect solar system, the heavens, with all that damage. So Walt's model, the hydroplate theory, explains how the solar system itself was corrupt with the stain of sin, how the heavens are seeing the same kind of decay as the Earth. The perfect cosmos now has asteroids and comets flying around, and they're dangerous. They kill people. Meteors, like errant bullets. The near side of the moon pummeled with the Maria compared to the mostly sprinkled far side of the moon. The biological material out in the solar system, if anybody goes to kgov.com/evidence and clicks on that link, there are dozens of papers where there's so much evidence that there's biological material not only on comets, but in meteoroids and out in space. All the transient lunar phenomenon, that the moon got beat up very recently. Comets and asteroids and even meteoroids with diamonds in them made of common earth minerals. How do you get the temperature and the pressure to make diamonds in asteroids? Brian, earlier you mentioned that the feature of rock in meteorites, I can't pronounce the word, where you need very high temperature over a long period of time to create that feature in iron.
Yeah, the Widmanstatin pattern between iron and nickel, that's one of the signatures that tells you whether or not you have just a chunk of iron or whether or not you have a meteorite, say if you're out looking for meteorites.
Yeah,
tests.
Right, and the hottest temperatures in the largest asteroids don't get nearly to the temperatures that you need. The Earth's oldest rock, yep. NASA hid this for 50 years. They didn't announce it until this year. The Earth's oldest rock based on radioactivity was found on the moon. So how'd that happen? How did a rock from the Earth get to the moon, and why does it have that much evidence of radioactive decay? It's because of the fountains of the Great Deep. Rounded boulders form in energetic flood flows, yet thousands or millions of rounded rocks are in comets. The biggest crater system in the solar system is in the southern Aitken Basin of our own relatively tiny moon. That's because the moon was closest and it got beat up so severely. Bronze Age iron came mostly from meteorites. That's generally unknown to the creation community. when the Bronze Age was making knives and tools from iron, it was almost all from meteorites. They're iron. And how could it be? Today, you wouldn't be able to sustain an industry if you're making tools only from meteorites. But after the flood, there was way more debris in Earth's orbit that rained down on our surface. Space debris thins out as you travel from Earth to the asteroid belt. You don't get more and more debris, you get less and less debris because the debris came from the Earth. That's why most debris in the solar system is in Earth's orbit. And it goes on and on. This list, these are extraordinary pieces of scientific evidence that gives powerful evidence, like swaths of missing crust in the Atlantic and a massive granitic crust below the Pacific. So guys, we could continue, but the mile deep sediments that blanket the continents, they had to be eroded from below because neither the vapor canopy nor catastrophic plate tectonics can explain where the sediments came from. So I think that's enough. There's a lot more.
Yeah, well, I was saying in the chat, Bob, that even though we've gone for 2.5 hours, because people are loving this, and we've actually got some fellow brothers and sisters and fellow young Earth creationists in the chat that aren't familiar with the HPT model. So already they've begun to download and order the book in the beginning. And I pointed out that even after 2.5 hours, we've only touched on maybe 1% of all the evidence for the model. So
yeah, exactly. And Walt's book is truly extraordinary, and it's his latest contribution is the origin of Earth's radioactivity, and he truly is the Isaac Newton of our day. And I think he needs to be honored, and he's so often attacked. Because he's the one who explained to the creation movement that the vapor canopy theory is not valid. It's not scientific and it's not biblical. So he took one for the team because the team loved the canopy theory. But now, decades later, the whole creation movement, at least all the big groups, they all acknowledge Walt was right, but it caused a rift. And once a relationship spoils, it's hard to repair it. So, but Walt really gets the credit for helping the creation movement in immeasurable ways.
I would like to say one thing that's kind of off topic, as in we discussed it earlier with the lightning strikes and how, because for the critics and a couple comments in the chat saying kind of just dismissing it, but the Z pinch, hasn't it been observed in the lightning strikes where the heavier nuclei have actually been created? Like this has been observed, and so
well, this is
they're outright dismiss. Right. So they're just dismissing that which is empirical and has been observed.
Yeah, lightning bolts create radioactivity. Scientists discover, which is hysterical because they discovered it where tens of thousands of Walt's readers knew about this for 10 years.
Right. So these heavy elements were being made in the Earth's crust during Noah's flood. And for them to just wave it away, because we've had a few comments from critics, and I'm just thinking like, were they listening to that portion? And
I'm sorry for interrupting, but
no, that's okay. Go ahead, Bob.
Here's the journal Nature. Lightning makes new isotopes. Physicists show that thunderstorms trigger nuclear reactions in the atmosphere. November 22nd, 2017. So, there's a lot that we discover in the world of science, and it's understandable that not all scientists and people who are interested, they can't be up on everything.
Right.
But Walt Brown students, they're up on way more than anyone else. All these discoveries, all scientists work for Walt Brown, and Walt Brown was here, his model is right. Therefore, his predictions are confirmed to an extraordinary degree, and he's made many outstanding explicit predictions that we know are going to be confirmed because his model has been confirmed by the scriptures and by the fulfilled predictions.
Amen. Amen. And like we said earlier, the gold standard of science, especially for any working hypothesis, is to make testable predictions that are both future and falsifiable. And I mean, we touched on a massive number of them today. So this has been phenomenal. George, I think you're about to say something, brother. I apologize.
Yeah, I was going to say we often hear from the atheists and evolutionists that if we ask them a question, they say, "Oh, we don't know, but we'll find out at some point in time because we know there's a naturalistic explanation." However, when we say it, somehow that debunks creationism, and I find that a bit funny though, because it's a double standard, if you like, you know.
Now, Bob, a lot of these testable predictions that Dr. Walt Brown that he's put forth in regards to the model, many of them have actually been confirmed and come true.
Yeah, that's
exactly
right. It's on Walt's website. We make it super easy. rsr.org/predictions. We list his predictions, the confirmed ones, and then we link to his book.
Because a lot of critics too that say, you know, it's almost like a full-time job criticizing and objecting to young Earth creation. They'll say, sure, you can make testable predictions all the time, but none have been confirmed. But that just shows that they're not up to date on the fact that no, many of them have actually been confirmed as well.
So many. If they go to that page, it will make them sick to their stomach.
Maybe it's why they avoid the page.
If they're rebelling against creation science, they will hate to see all the explicit predictions confirmed.
Right, right. So when they say that none have been confirmed, it just shows that they're not up to date. As you said, one final thing I'd ask then, with the Proton 21 lab, I've had a couple people say that they've they're saying it's disappeared. Are you familiar with this or what?
Well, it closed down, Brian. Maybe you know more, but yeah, it closed down.
Yeah, I haven't heard anything about. I guess I actually wasn't even aware of it, so I'm not up on that. But it certainly was in operation at some point, and
right. It doesn't negate the data.
Yeah, it does. A very good point. It doesn't negate their results or what they found.
Well, not only that, but at Sandia National Labs, they began to, science, observable, reproducible. They began to reproduce their results, and their initial, and not only there, but in the US, in Russia, Germany, Sweden, at the Department for Applied Physics and Electronics at Umeå University, they are getting preliminary results that are consistent with the Proton 21 published papers. And at Sandia, they said, and I could, I think I could pull up the paper, but here, Proton 21 experiments in the Ukraine and at US Sandia National Labs, I'll click on that and see what we get. On our website, we link to the original sources thousands of times. And here, November 2009, and if you go through and read this like we have, they are very optimistic. Their data is consistent that Z-pinch will create elements, and they ask for, unsurprisingly, a government lab, they ask for more money to further their research. And if that money ever materializes, we know that it's going to show that Proton 21 was spot on.
Right. Great point. I've heard you, Bob. It was I think it was in that recent show actually that you had with Brian about the heat problem, where one of the predictions with the mammoths, somebody said that was a prediction that Dr. Brown made, and it was falsified due to where some mammoths were found. And I remember you refuting that claim. I just can't remember exactly what you said. It was
Yeah.
Could you touch on that real quick? Because somebody is saying, why do we find mammoths below oil then, which formed during hydroplate?
Okay. So, and Brian, you might recall better, but There was a paper written by a creationist, very well-known creationist, and he's going to publish that falsifying Walt's prediction because we found fossils below in the Arctic Circle, below sedimentary layers. I'm trying to recall the details. Walt contacted the author and pointed out, because thankfully he got a courtesy copy. I wish that happened more often. This is a famous creationist, and I hesitate to say his name, but he misread the sedimentological maps, and he was wrong about the location. So that paper was not published. Now, perhaps someone commenting knows more about that or a different case, but I'm not familiar with it.
Yes. Yeah. Actually, what you just said, Bob, is exactly what I remember from that show. So I got to say, gentlemen, I mean, we're going on 2 hours and 40 minutes, and this has been amazing. I'd love to have you on again, Bob. I mean, we've only touched on 1% or maybe even less of the evidence and what we could say about HPT. But I don't want to keep you guys any longer. This has been a blessing. I really appreciate the time that you gentlemen, you brothers, have given to us. You've been a blessing to not only us, but also our listeners, our faithful listeners. We've had a very good audience the entire time. So God bless you guys. I want to give you gentlemen the final words, and George, of course, if you want to say anything as well before I think we shut it down for the day.
Well, I'd like to thank you both for coming to our show, but also please feel free. I'll volunteer Standing for Truth to come on to your radio show.
Okay, we will do that. I take you guys up on that, so we'll book it. Good. Book it, Daniel.
Awesome. That's awesome. You guys are a blessing. Once again, thanks for giving us your time. You guys can have the floor for some final words. And Bryan, I know you were at work, so we appreciate you making your way in here and giving us so much good information on some very technical questions. So extremely helpful. And I'm going to probably rewatch this tonight because so much good information, guys.
So Bryan, do you have anything? I know you got to go.
Yeah, I guess I'll give a shameless plug for anybody who wants a little more information that comes from my perspective on interpreting hydroplate theory, and helpful information in terms of understanding it would be to go to my YouTube channel just under my same name. My name is spelled with a Y, and look that up. And there's several hours of content there that should help anybody who wants to get a little better understanding of hydroplate theory, get them up to speed pretty well.
Amen, Bryan. I was just watching your series again last night, actually, in preparation for this, and I can't recommend it enough. So I'm going to also put that in the description box of this video, so people will know where to go easily. So I appreciate that. Yeah,
you bet.
And Bob, I'll leave it up to you for some final words, and thanks again.
Well, I couldn't more highly recommend Bryan's videos, and we link to them constantly from our website, and especially his video on the origin of Earth's radioactivity. That's Walt's latest contribution, and it's a brilliant discovery. He deserves a Nobel Prize for the discovery of the origin of uranium. Walt Brown was
Amen.
Prize. And on our website, if you notice, we've got HPT. Notice that doesn't say HTTPS. Well, that's on the left, but you could ignore that. HPT.rsr.org. Walt has given us permission to reproduce his website here. And so home, online book, which is HTML, the flip book, which is so fun to read, and a downloadable PDF in an HPT store where you can get really fabulous hydroplate theory resources. Mike Snavely, Mike's mission imperative, he is the home of the upcoming 9th edition of Walt's book. So the hardcover book will be available from Mike Snavely. And I know Bryan Nickel, it's his passion, but to get out this heat video on Walt's model, and we will continue with God's help and blessing to produce resources. See Brian's Origin of the Grand Canyon right there, that stunning video that you can see on his website, and you could get right here from the Hydroplate Theory store. So it's all there, and we're thrilled that you guys are fighting the fight, and we're thrilled to stand alongside you.
Oh, thank you. Thanks, Brian. I've watched your videos numerous times.
Yeah, well, that's I go back and watch them a lot too, just to remind myself of stuff. So, yeah.
Good on you, mate.
Well said, gentlemen. Thank you again. The chat had a great time. I had a great time. I learned so much. So looking forward to having you gentlemen back on in the future. And thanks so much for all you do, because we wouldn't be here if it wasn't for men like you that we can learn so much from. So anyways, God bless you and God bless the chat. Thank you so much, guys, for sticking with us for nearly 3 hours. Time has flown by.